All right, here we are, logs, day 5. We're gonna practice solving equations using logs and that have log in it. So logarithmic equations and exponential equations. So first important thing are one-to-one properties. So if you have a to the x power, that's gonna equal a to the y power as long as x and y are equal. All right, so what does that mean? It means if you have two numbers that have the same base, then their exponents have to be equal. Like if you had like 3 to the x power equals 3 squared, then x has to equal 2 because these bases are the same. So for some equations, you have like an exponential on both sides. As long as the bases are equal, you could just set the exponents equal. All right. Same thing with logs. If you have the log base a of x equal to the log base a of something else, as long as the bases are the same, then the number inside the logs have to equal each other. So if you had like the log of x plus 2, and I just wrote log, so that would be like base 10. And that's equal to the log of 7 base 10. Even though we don't know what the log of 7 is, we could still set these equal because it's the same log base 10 on both sides. All right. And then there's also inverse properties. So you could, if you have an exponent raised to a power with a log and the base of that log is equal to the base of the exponent, then it's just going to equal x. Because if you think about it, right, a is your base, log of x base a is your exponent, and x is your answer. So if you put that into log form, all right, log base a, because a is your base, of our answer, so which is x, bacon, and eggs, equals the exponent, which is log of x base a, all right, that's obviously true because both sides of the equation are the same. Same thing here, if you have the log of something like a to the x power, and the base of that exponent is the same as the base of the log, they'll just cancel out and you get x. So again, you could prove that pretty easily by putting this into exponential form. So bacon and eggs, a is your base, a is your answer. So a is your base, a to the x is your answer, and e is your exponent. So both sides are equal. So let's try some of these simpler equations. No problem. Ooh, nice. Okay. So let's solve these. All right, so for number 1, I mean, you could probably just do this in your head and say, all right, x is 5, because the other way to do it would be put it into log form. So like, all right, your base is 2, your answer is 32, and your exponent is x. But if I were to evaluate this without a calculator, I would be thinking in my head, all right, 2 to the what power equals 32. And I would do, all right, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, times 2 again is 32. So x is 5. So if you didn't know that, then you could just type this into your calculator and you would get 5 for x, all right? Now, if you ever have an equation with multiple log expressions on the same side of the equation, what you could do is condense it using the properties of logs. So the natural log of x minus the natural log of 3 would simplify to the natural log of x over 3. All right. Remember that natural log just means that the base is e. So you can then take that and put it into exponential form. Base is e, answer is x over 3, and your exponent is 0. All right, so now you could take e to the 0 power, and that's something that you can evaluate. That's just going to equal 1, because anything to the 0 power is 1. And then you could cross multiply, and you get x is equal to 3. And if you think about it, I mean, if you plug that back in, that makes sense because it's natural log of 3 minus the natural log of 3. It's the same thing minus itself. So that should equal each other. All right. Number 3 is very similar to number 1. You can either put it into log form or think, all right, well, 9 is equal to 3 squared. All right, and if I found the reciprocal of 3, that'd be 1/3. So like 1/3 to the -1 power is equal to 3. And then if you square that, that's equal to 9. So basically 9 is equal to 1/3 to the -2nd power. So then you can use the 1-to-1 property, which is written up there. You can't see it. And since the bases are equal, you could just set x equal to -2. So that would be our answer there. And then something like number 4 is just not possible, because if you ever were to, like we've graphed logs before, what am I talking about? It is possible. I'm sorry, I lied. So let's do it. I was thinking of something else, so my apologies. But if there's no base written, you assume it's 10. So then you could put it into exponential form. So base is 10, answer is x, and then your exponent is 1. All right, so basically like something we keep coming back to is putting it from log form to exponential form, and from exponential form to log form. All right, anytime you have a variable like inside the log, then take it out of log form, put it in exponential form. Anytime you have a variable in an exponent, take it out of exponential form and then put it into log form, like we did for number 1. All right, so for number 4, x is equal to 10 to the -1st power. All right, and that's just 1/10. All right. So let's put that together for more complicated stuff. But if that made sense, then everything else is simply review. It's just solving equations like you've been doing for the last like 5 years, since like middle school. All right. So instead of like solving for x, when we have an exponential equation, we're going to solve for the exponential expression. So we're going to get that e to the 2x alone. All right. And then worry about the 2x part later. So our first step is going to be dividing both sides by 4 to get that exponential expression alone. All right, I'm going to try this for a second. We'll see how it works. So now I have e to the 2x equals 5/4. I'm using some sort of new writing thing, so we'll see if you notice the difference. If you do, if you notice it gets really sloppy, let me know. I just switched up mid-lesson. All right, so now we need to get the x out of the exponent. So this is where you're going to put it into exponential form, or it's already in exponential form, but we're going to put it in log form. That's your base. This is your answer. And then this is your exponent. Up. That was up. E's are hard. All right. So in log form, that's going to be log base e, because that's your base, of 5/4. All right. And then equals 2x. Now, if you wanted to get this as a decimal, you could then just type this in your calculator, this number here, the natural log of 5/4, because that's what it means to be base e. All right, equals 2. Then you could divide both sides by 2 to get x alone. All right, and that's your answer. And that's totally fine to leave it like that. But if you wanted to do that as a decimal, all you'd have to do is, like I said, type it into your calculator and see what that equals as a decimal. You would never have to do that by hand. All right. Any questions so far while we wait a second for this to load? Okay, so now once you have the x isolated, I know I have a bunch of things on my, things keep popping up. All right, now you just type in natural log. So that's usually a button right on the calculator near the E. So control natural log. All right, of 5/4. So it's the natural log of 5/4. And then that whole thing is divided by 2. So if we wanted to get that as a decimal, all right, we type it in and we get 0.11157. All right. So now same thing with number 2. Instead of isolating x to start, we're going to isolate this exponential expression. So we're going to get this part here alone. So like basically like we're going to start off solving it like it's 2x minus 4 plus 11. So what we would do is first bring the 4 over to the other side. So add 4 to both sides. All right, then we could divide both sides by 2. So now we have 3 to the 2x minus 5 power is equal to 15 over 2. So 11 plus 4 divided by 2, which is 7.5. All right, so always isolate the exponential expression first. And we did that. Now, once it's isolated, now we're going to put it into log form. So that's our base. 2x minus 5 is our exponent. And 7.5 is our answer. So in log form, that would be log base 3 of 7.5 equals 2x minus 5. All right, now it's just like solving for x, just like we've done our whole careers as math students. All right, so if you wanted to, you could like keep this, and then especially if it said give an exact answer, you want to keep that as the log of 7.5 base 3. But if it said round to a decimal, either now or at the end, you can convert that to a decimal with the calculator. So to solve for x, I'm going to add 5 to both sides. So bring that over to the other side by adding 5. And then divide both sides by 2. All right, and that's our answer. And I would be fine with you writing it like that. And you would have to write it like that if it said give an exact answer. Now, if you wanted to get that as a decimal, then you would take your calculator and you would do, all right, the log. So control log base 3 of 7.5. All right, so you can, figure out what that is, and then add 5 to it, and then divide by 2. So it comes out to be 3.417. And you can always check your work by plugging it back in. Always a good practice. All right, so take the equation 2 times 3 to the power of 2 times, we'll round this answer, 3.417 minus 5, and then minus 4. And it comes out to be pretty close to 11, close enough where I feel confident that we didn't make any mistakes. The reason why it's not 11 exactly is because we didn't re-rounded. All right, but a cool thing you could do is instead of like rewriting that, if you have a TI Inspire, if you hold the cursor where you want something pasted, you can arrow up and then hit enter, and it'll copy and paste it to that spot. All right, and then you get a more accurate approximation, and you get the answer 11. All right. Now, 3 is a little different. All right, we have to treat this one like a quadratic because it kind of resembles a quadratic. Now, I'll ease some of your concerns that you might have. You won't get something like this on a test, right? If you're watching this in the year 2021, can't make that guarantee for other classes. But I want you to just not be intimidated by this and just be like, all right, I'm going to figure out how to do this, because it's really not that bad. All right, it's just like a quadratic equation. The only difference is instead of having like x squared minus 3x plus 2 equals 0, in place of x, you have e to the x. So what we could do is like temporarily substitute like another variable in for e to the x. And this is a cool trick that you'll learn when you get to calculus. It's called like U or A substitution. And basically you could take like a part of an equation that's kind of complicated and substitute it for something more simple. And then later, whatever you get for A, you could plug that back in there. So it's basically like you're taking one complicated equation and breaking it down into 2 simpler equations. So now we could solve this purple equation on the bottom here by factoring. So you get A minus 2 times A minus 1 equals 0. All right, so then when you set each factor equal to 0 and solve, you get A equals 1 or A equals 2, which you could all do, even if that original equation seemed intimidating. Now, all you have to do is take A away and replace e to the x. So instead of saying A is 1, you say e to the x is 1, or e to the x is equal to 2. All right, and then to get our answers, now we'll put this into exponential form. So your base is e, so base e is natural log. All right, your answer is 1, and your exponent is x. All right, now that's going to simplify to 0, because anytime you take the log of 1, it's going to equal 0. That's because if you look at the step right above, like anything to the 0 power is 1. Now, the other one doesn't work as nicely, all right? You need a calculator to figure out that decimal, but the base is still e, the answer is 2, and the exponent is x. So that'd be your other answer. You could just leave it like that, all right, natural log of 2. Or if you wanted to put that as a decimal, then just simply type it in your calculator. All right. If you have questions, let me know, or you could wait a couple minutes. We're almost done. You can ask anything you'd like. But don't hesitate if you want to ask soon. All right, I am recording this, so I'll upload it as soon as we're done. All right, these last, there's 4 more. All right, so now logarithmic equations basically work the same way. If you have more than one log in number 5, I'll show you what to do in a second. But if you just have one log expression, it works just like an exponential expression where you want to isolate the log part and then go from log form to exponential form. So first thing we're going to do is subtract 5 on both sides. So we get the natural log of x is equal to -1. And then you could divide both sides by 2. So we get the natural log of x is equal to -1/2. Now remember, natural log means the base is e. So we can now take this log expression and put it into exponential form. Base is e, answer is x, and the exponent is -1/2. So e to -1/2. All right, and that's just a number. All right, e is around 2.7. So like that's essentially 1 divided by the square root of 2.7. All right, so I would never ask you to like do that in your head. You can either just leave it like this, or if it said give an exact answer, if it said to approximate your decimal, then you would type that in your calculator, type E. So make sure you don't hit E down here, because that just means like the letter E, like, Edward. But this E here is the mathematical, oops, so I hit second, I shouldn't have done that. So just hit E to the X, that's the mathematical constant E, right? If I do E to the first, all right, it's gonna be silly and tell me E, but if I approximate it, it tells me it's around 2.7. So if I was actually doing this problem here, e to the -1/2, I would just type in -1/2, control enter, and we get 0.6. And you can plug that back in and make sure that it's close, all right, and it is. No, don't do that, cancel. Nice, someone just joined, that's cool. All right, number 5. So number 5, we now have 2 log expressions. So if it's like this, where it's one log expression equal to another log expression, this is actually much more simple because we can use this one-to-one property above, where right here, where the log of x base a equals the log of y base a. If that's the case, then x equals y. So you could set those equal to each other, the expressions inside the log. So you could set 5x minus 1 equal to x plus 7. All right, and then go from there. Subtract x on both sides, add 1 on both sides, divide by 4, bada bing, bada boom, x is 2. If you plug it back in, it makes sense because then you get, all right, the log of 5 times 2 minus 1 is 9. So the log of 9 base 3 is equal to the log of 2 plus 7 base 3. So log of 9 base 3. So obviously they're equal, it's the same thing. And they're both equal to 2 because 3 squared is 9. So when you have a log equal to a log and the bases are the same, just set those expressions equal to each other and you're good to go. All right. 6, very similar to number 4, the one we did 2 problems earlier. All right, so you can divide both sides by 2. because we always want to isolate either the log or exponential expression first. So we do that by dividing both sides by 2. All right, then you could take that, and once it's isolated, put it into exponential form. So this is your base, that's your answer, and this is your exponent, bacon and eggs. So we get 5 squared equals 3x, divide both sides by 3, and you get 25 over 3. All right, and that's it. Plug that in, you would get 4. Okay. All right, last one, we have 3 log expressions. So what we want to do is condense both sides so that it, oops, awkward, how embarrassing. So we want to condense both sides in number 7 so that it looks like number 5. So it's like the log of something, so it's log of base 3 equals, oh, let me say it again. So we want to condense both sides so we get like the log of something equals a log of something where the bases are the same. So on the left, we're adding these two. So we could condense this using multiplication. So like the log of A plus the log of B is going to equal the log of A times B. So the log of x minus 2 plus the natural log of 2x minus 3 is going to be the natural log of x minus 2 times 2x minus 3. And then on the right side, all right, we have that 2 out in front. We need to get rid of that. So we can do that by condensing it using exponents. So that's another rule for condensing logs. If you have like a multiplier outside the log of something, you can bring it out as like an exponent. All right, and that's to do with exponent rules. All right, so now since we did that, it's the natural log of one thing equals the natural log of something else. That means that these expressions have to equal each other. So we're going to set this equal to that. So once we do that, I'm going to FOIL out the left side. So I get 2x squared minus 3x minus 4x plus 6 equals x squared. Okay, so now it's just a quadratic equation. So we could put this into standard form. So bring this x squared over on the other side. So that becomes just an x squared. All right. These two we could condense, or we can add, get negative 7x plus 6 equals 0. All right, now we're going to factor that. So we get x minus 6 times x minus 1, which means that x should equal 6 or 1. Now, something that you have to be careful of with log equations are extraneous solutions, which I believe we saw back when we did like square root equations. But basically they're solutions that you get that aren't actually solutions because of things like domain restrictions or squaring both sides. Basically, when you do those things, when you square both sides, or like we did here, when we multiply these two together, all right, if they're both negative, when you multiply them together, they could come out to be positive, which these can't be negative because you can't take the log of a negative. So when we condense it, we do create the opportunity for solutions that don't actually work. So I know I didn't explain why really well, but basically all you need to know is that just check your answers and don't be surprised if you get one that doesn't work. It could be extraneous. All right, and I'll explain better right now how that happened. So our solutions were x equals 6 or 1. All right, let's plug in 1 real quick. So 1 there, a 1 there, and a 1 there. So this is the natural log of negative 1, which bang, right there, not possible. So 1's going to be an extraneous solution. But how could that have happened? Well, This is 2 minus 3, so that's -1 as well. Bang, another natural log of -1, which is not possible. You can't take the log of negative numbers, all right, times natural log of 1. Now, if we were to condense this here on the left, you would multiply those together, and -1 times -1 is +1. All right, and then if you condense this here, you get the natural log of 1 squared. So this is true, but that's not the original equation. Like this was the original equation, and like this is not possible. So that's why that happens. It's not super important that you know why it happens. I just feel like as your teacher, I should show you why that happens. And it has to do with the two negatives being multiplied into a positive. But so if we were answering this, we would cross off 1 as a solution and then double check to see if 6 works. And if you plug in 6 here and here and here, all right, we get the natural log of 4 plus the natural log of 9 equals 2 times the natural log of 6. All right, and that's going to be true because there's no domain like restrictions. And then we get the natural log of 36 equals, by multiplying 4 and 9, equals the natural log of 36 by condensing this by bringing the 2 over here. And bang, we're good. So that is how you solve log and exponential equations. And we'll practice that more tomorrow. But if you have any questions, please let me know. I'm going to end this video here.